Okay, this is basically just my notes on econometrics. Notes I gathered together either from Mr. Bushi's class, Dr. Odian's class, or Dr. DBC's class, and also from textbooks. So I'm going to advise that you do a thorough reading, because this basically just the video will basically be on probably OLS assumptions, test of significance, and provings. Other parts I'll just run through them so that we have a basic understanding, and the focus is on examination. This is basically for examination purpose, not for practical purpose. So I will only attempt or try to explain things that I feel might be important for examination. And as you know, the exam is on Tuesday afternoon. I still believe you can still do your own personal thorough reading. It's very essential. It's very essential. So going straight to the point, starting with what exactly is econometrics. Econometrics is basically a point where economic theory confronts with reality. We are just trying to say that all our economic theory in economics, they are basically based on assumptions. We tend to ignore the reality and focus on, let's assume this is this. That does not mean they are not true. No, it's totally different from not being true. Many of them are true, but still based on so many assumptions. When we want to state the law of demand, we have this assumption that yes, let's say ceteris paribus, all things are held constant. This is an assumption. It does not mean the law of demand is false. No, many times it's true, but we still have this limitation that we put to it due to this assumption. So, but with econometrics, we now want to look at the reality. Let's face the reality. Most of these assumptions doesn't exist in the real world. So, econometrics want to make this economic theory be faced with reality. Will demand rise? Will the law of demand take place even if we remove all these assumptions? So, we want to use data to face or confront this reality, because many of our economic theory are just qualitative. We tend to give qualities, what should happen when this happen. Many of them lack specific figures, but econometrics too wants to solve that particular issue. Now another thing is mathematical economics is different from econometrics in the sense that mathematical economics is basically still our economic theory. We are just not saying it in words. We are using mathematics to depict this. So it does not really change anything about the theory. It still remains the theory. It's not trying to test or verify the theory by looking at data or observing some data. No, it's just expressing this theory mathematically. But in econometrics, we tend to want to observe, want to check some data and see the reality of this particular theory. That's what we want to do in econometrics. Now the good news is that everything we are doing is just in this particular scope I am about to show you, that is on your screen right now. This scope is just basically everything we are doing. Now mind you, I'm not saying that econometrics is basically this is everything about econometrics. No, but everything we are doing can find itself in one of these particular page that you can see right now. Now you can remember we started with the methodologies, which there are 8 in numbers. We are still coming to that now. After that methodology, we do so many other things which it seems so scattered. So I try to bring them together so that we can see that this is it's actually a short outline. Yet it can be confusing, but it is actually a short outline which I believe you can actually prepare for and do better. Now this 8 methodology, if you remember, we have the 8 process, or let me call it process. The methodologies, there are 8. Now the 5th one is estimation, and the 6th one is hypothesis testing. Now everything we are doing this semester is basically on these 2. Everything. Is it the one Mr. Bushi is teaching us, Dr. Odio or Dr. DBC? Everything is within this particular scope. Now the method 5 is talking about estimation. That's where it talks about OLS. The method 6 is talking about hypothesis testing. Now under the method 5, which is the estimation, that's where we talk about regression, and we talk about the types of regression, the linear and the multiple. The linear is the one we use OLS for. Now under that linear, we talk about linearity, population regression function, sample regression function. We talk about the formula for estimation. We talk about the interpretation of our function. We talk about the problem of estimation, the properties, assumptions, and so many other things. So it is still under this scope. And under the hypothesis testing, which is the method 6, we talk about many things which can be grouped into 3: the theoretical or a priori testing, the statistical, and the econometric. Under the statistical is when we talk about R-square, which is the coefficient of determination. We also talk about the standard error under this. While the econometrics talk about autocorrelation, multicollinearity, heteroscedasticity, and model specification. Now this is just everything we are doing this particular semester, so it is not that wide, but you have to just be careful to understand them better so that you will not miss the concept. Trust me, it can be easily misunderstood, but it can also be easily understood. You just have to find the right time, the right place to study it and get it right. So that's the scope. Now let's go to the methodology. What are the methodology? As I said earlier, the 8th methodology is the one that opened the whole gateway to everything we are going to study. Now these are the 8th methodology. I'm very sure many of us are familiar with this and we can easily read that on our own. The first is statement of the theories. That means we are stating the theory itself, the economic theory. Is it the law of demand? Is it the law of absolute income? Is it the law of this, law of that? We are stating the theory or the hypothesis itself. Now mind you, I said the methodology, we are focusing on method 5 and 6. That does not mean that every other method are not important. They are very important. I am just talking about academically for our semester. We are only focusing on this method 5 and method 6. This guy and this guy here. Yeah, let me take my highlighter pen. So we are basically looking at this and this for this semester too. That's basically what we are doing this semester. Does not mean this and others are not important. Very, very important, but at one point or the other we might have done them before, or we might still do them in the future. So the statement of theory. The second one is specification of math model. That means you convert your theory into mathematical terms. So your theory that is written in words, you are converting into mathematical terms. The next is that you are specifying your statistical model. Then you are transforming from your mathematical term to econometric model. Remember that these two, they are not facing reality. We have so many assumptions. I repeat again, does not mean that they are not true. But they have so many assumptions related to them. But now we want to convert it to an econometric model, facing it with reality. Let's see what does the real world says. So that's what we are doing at this particular third step. The next is obtaining data. Yes, statistics, econometrics is about data. How can you know if it's true or not? You have to gather data. It's basically data you are using. So at this part, this is where we obtain data. Basically, for our variables, we obtain data, the past data. What do we know about this variable before? So we obtain it. Then the fifth one, which I said is one of our focus, is estimation of parameters. The parameters are the beta 1 and beta 0. Beta 0 and beta 1. Now in some textbooks, or you personally, you might be using beta 1 and 2. It doesn't matter. Just know that beta 0 will now be beta 1 if you are using 1 and 2, and beta 1 will be beta 2. So these are the two parameters. So we want to estimate these parameters. We want to estimate, we want to calculate these parameters. But we know we might not be perfectly accurate with the calculation, but we don't mind, just want to estimate and get the best estimate for these two parameters. Then the sixth one is that we want to test the hypothesis. Now after estimating this parameter, we want to test how good these parameters are. We want to see how well are they representing what we want them to represent. So we want to still give it a test. Just like when you create something new, you don't want to just go out there and sell it in the market. You want to test it. How good is it? Is it actually solving the problem I am about to solve? Then the seventh one is that you forecast and predict. By the time you are able to test and you are sure that okay, this particular law is working, then you can use it to forecast and make predictions. All these are useless. We are not just doing this for the fun of it. We basically want to make decisions with it. So with everything we have done so far, we can forecast and predict, then we can formulate policy. So those are the methodologies in econometrics. So before we go further into every other part, I think this is very, very important we talk about now the sample and population. Many of us have been hearing sampling, the population, blah blah blah, and it's kind of confusing to many of us. Yeah, sure, it's confusing to many of us, even to me too, at one point or the other. So what do we actually mean by sample and population? Yeah, population is basically everyone. Let me just say everyone. Yeah, population is a very large number, like what we have here now. You can see this is a population. Now the problem is that if you want to obtain data, remember the method 4 or 5. If you want to obtain data, you have to obtain data from what has happened in the past, what has happened to people in the past. And what are the people? These are the population. If we, like for example, want to study, well, our study is all about men in Nigeria. If you want to like obtain data, if you want to get the perfect data, you have to get the data from every single man in Nigeria, and we are talking about millions of people here. So that is the population. This is definitely not possible to do. Impossible, expensive, frustrating, and so many other things that are related to it. But we still need this particular information. So because of this, that's why we decide to use samples to represent our population, and we do this every day. Not just economists do this. Many of us will make decisions based on samples. We don't tend to like wait till we get all the facts we need before we make decision. We make decisions based on samples. That's just it. For example, why do you believe when you buy a pen it's supposed to work? Have you actually tried using all the pen on earth? No, it's not possible. None of us have tested all the pen on earth and tested them to be working before we now believe that yes, when I buy a pen it's supposed to work. No, but we have used few pens before in the past. That's data. We have used few pens in the past and we see them working, so we believe when I buy a new pen it's meant to work. Not that I've actually tested that pen before that I want to buy. No, but because I have used some pen in the past. So those are my samples. So that's why economists now use a very small number of people's samples. Now the problem is now that if you are taking samples, how do you now make sure that this sample is representing this population? We are talking about 100 million people here. I want to talk about what out of this 100 million people, how many of them are using glasses? So if you decide to go to a family, and because the family all of them have eye problem, all of them are using glasses, you may be confused, or you may be forced to conclude that every man in Nigeria is using glasses, whereas it's basically your sample that you picked that many of them are using glasses. So you want to ensure that this sample is representing this population. So that's why it is not really easy to do. So that's basically the relationship between sample and population. And that's what we tend to do in econometrics. We tend to like find a sample that can represent our population. That's what we are doing. Now that is why we now have things like sample function, population function, regression function, sample regression function, which we are still coming to very soon. So that is sample and population. Now let's move straight away, I think, to the last part of this first video. This is just like introduction for us to get the basic knowledge. Now, economic data, we have heard about the time series data, cross-sectional data, panel or pool data. What do they actually mean? Now the time series data is basically represented by T. That's when you see that when we are talking about xt, this small t that we put down here. Now the t is not just here to occupy space, or when we say yt, we are talking about time series data. And what do we mean by that? Time series data are basically a type of data whereby you are talking about a particular subject, but you are now looking at the what is happening to that subject over time, over a period of time. So let's say, for example, we are talking about what would I say, the height. Let me say the height of a boy, but you are not looking at the height of that boy, just one person though. You are looking at the height of that boy at age 2, at age 4, at age 6. Now can you see, what are you still looking at? Is still one subject, height, but you are looking at his height at different time over a period of time. That's time series. It's still one single subject, but it is over time. So also is when you are looking at some economic figure. For example, you are looking at demand in a particular market in the year 2001, the year 2002, the year 2003, the year 2004. You're actually looking at one particular thing, just demand, but it is now over time, over a period of time. But cross-sectional data is different from time series because you are looking at many subjects at a particular point in time. You are looking at many subjects at a particular point in time. So let me take this height example. For example, you are now looking at height of 5 boys, A, B, C, D. Okay, let me use 4 boys. Height of 4 boys at a particular point in time when they are all 3 years old, for example, or in the year 2020, for example. So you are looking at height of 4 different subjects, but it is at a particular point in time. That's cross-sectional. Now cross-sectional is always having I. That's why you see sometimes our Y will be YI, or our T should be, our T will be, our X will be XI. So cross-sectional is basically many subjects at a particular point in time. While panel or pool data, some people may try to differentiate panel or pool. Some people may try to differentiate panel or pool data different. Some people may try to differentiate panel or pool data separately, but I'm just going to merge them together. That's not what we are focusing on right now. So panel or pool data is just a combination of the two. For example, you are looking at the height of 4 different subjects or 4 different people over a period of time. So can you see that we have 4 different subjects now? We now have a lot of time, as in over time. It's not a point in time like cross-sectional again. It is now many subjects over time. So time series, let me clear this. I just summarize. So time series is subject over time. Cross-sectional, many subjects at a point in time. Pool data is now combination. It takes many subjects from here, but instead of taking them at a point in time, it now take them over time. That's pool data. So that's the difference between the three of them. This one is T, this one have I. So material have this one as IT, but we rarely use that in our functions. We basically use I and T. So I hope we get that. So I'm just going to end this video now and try to do another one for regression OLS. Remember, I said earlier that everything we are doing is just in this scope. So we have gone through this methodology and some other things that I think we might need. So let's now come to this first part, estimation, before we go to this hypothesis testing. Estimation is the method 5 in our methodology. So we want to look at how do we estimate before we now come to hypothesis testing. Thank you.